All right, here we go. Okay, tell me in the chat if I'm lagging, and I'll pause this, but hopefully it'll work. All right, guys, hey, we're looking at this right here. We're looking at building functions, okay? We're building functions from tables. We're going to build linear functions, and then we're going to build exponential functions. But it's really a matter of, like we were talking before, the positioning of my different parts of a formula. I know that m is always in front of x. It's a coefficient of x. M is the rate of change. It's like the slope, how much you increase from one value to the next. Our b value is our initial value. It's when time is 0. It's when time is 0. It's what you start with. And as far as a graph goes, we don't have to graph these. But the graph of this would be the b value is the y-intercept, because that's when time is 0. Okay, it's a side point. But let's look at level 1 here. We're using a table to find, actually add this right here. Use a table to find the equation. Right? We're just using the table to find the equation. Now, we have a table here, x and y, games played versus how much money you earn, right? Games played versus how much money you earn. Maybe you're a walk-on for a professional team, under 20 professional team, you get paid to, play a game, play soccer or volleyball. Now, the games, this information isn't always in order. So first off, it must be in order. The game, see how it's 0, 1, 2, 3? That's what I mean by order. 0, 1, 2, 3. It's always got to be in that order. If it was like 2, 1, 0, 3, that wouldn't make sense. We won't be able to get our information as we need it. So always have it in order like so. And then when I look at this, the difference is the rate of change. The difference is the rate of change. The difference is going to be looking at where you got to and how far you had to go. If at 0 games I have $5, that's just my initial amount. Right? Because after 0 games, I haven't played any games yet. I got $5 in my pocket. I have not been paid for the games I play. So at 0 games, we have $5, which is our initial amount. Look what we just figured out. Our initial amount is our b value. I wrote it as initial value here, but initial amount and initial value, you guys know that's synonymous, right? Yeah, of course. So look, the difference is going to be our rate of change. How much do we change for each game that we play? What is our rate of change? So for instance, from 0 games to 1 games, right? I have 1 game and an amount of money that I earned for that game. The way that we're going to find this is we're going to take the current value we're looking at to find the difference, the rate of change. We're going to take 6 and we're going to subtract the prior. Right? Subtract 5. We get 1. All right. We're going to take 7. We're going to subtract the prior. We got 1. We're going to take 8. We got to 8. We're going to subtract the prior. We get 1. Okay. You see how all these match? All these match, right? They match because you increase the difference. The rate of change is the same as you move through your games. So how much are you paid per game? How much are you paid per game? What do you think? $1. Big money, big spender. Maybe this is like 1920. It's 100 years ago. So for $1, you go and you can buy a bike. You could buy like a skateboard. Actually, they didn't have skateboards 100 years ago. All right, so this is the key. We're really just affirming what the common difference is. I know that the difference, the rate of change is $1 per game. $1 per game. So guess what we know? We know our b value, 5. So we know our b value equals 5. We know our m value equals 1. Right? And now it's just about, putting your hat on top of your head instead of on your foot. You put your socks on your feet instead of on your hands. Where are we going to put these two pieces of information if we have a linear equation that is this map? Here's our map. So go ahead and write my equation that I'm going to end up with. What am I going to end up with here? Go ahead and put that in the chat, please. Remember, we use this as a map. We have our pieces of the information. Go ahead and input it and let me know. Good, Cadence. Perfect. Good, Yancy. Perfect. Yep, Haley. Good. You didn't even put the 1. That's perfect. So you don't have to say 1x because it's just x, right? You don't have to say, I would like 1 apple. You say, I'd like an apple. What if you always said 1 before things? I only have 1 pencil. I have 1. Go get your 1 calculator. No. Let's see. Haley, good. Janice, good. Mia, perfect. Jordan, lie, perfect. We are going to end up with 1x plus 5. You notice I didn't put 1x. I just put x because it's the first x. It kind of says it on its own that there's 1 of them. Okay. All right, thumbs up, sideways down for getting this out of the table, putting the information in. Perfect. Okay, good. I see all. Thank you for the thumbs up symbols you guys are just throwing if your video's off. Now, we have a level 2 here, but I'm confident in you guys. I'm confident because if not given the initial amount, you see, I don't know how much I have in my pocket at 0 games. I don't know how much I have in my pocket at 0 games. I'm not given the initial amount. So we're going to have to figure out the initial amount, but it's not going to be too mind-blowing, okay? But let's fill out, well, my suggestion is to plug in 1 point, x, y, and solve for b. We're going to get to it. We're going to get there, okay? But let's do these differences first. We don't know what comes before the second game, so I'm just going to put, this is like a, I'll just put a star there. We don't know what happened before the second game, so we can't subtract it. We can't see. We can't make a difference. Okay. Now, looking here, how did we go from game 3 to game 2? How much did we earn? Maybe you could see that you earned $2. If you couldn't see that, you can go 9 minus 7, 2. Let's keep going. 11 minus 9, 2. It's just confirming that we have the same increment, just like sequences had increments between each term. We have the increment of 2. What are we trying to find with the difference? We're trying to find our slope. So look, I do know that my slope is 2, right? So if I am going here and plugging in to my equation, I'd put 2x plus b. So really, what do we need? Tell me in the chat, what's the one thing we need in order to be done with this problem? What's the one thing we need? Good, Haley. You're on it. Anybody else? All right. Good, Mia. Initial amount. Good. Rocco, Arnold, Sophia, initial amount. Good. Cadence. Good, good, good. We need to know this. We need to know that. So even what I'm going to do here is I'm going to get some whiteout tape. Okay, that worked finally. And I'm going to leave this open because if we could find b, we could put it into this equation and we'll be done. And we'll be done. Okay? So now the question, this is where I would have you turn to your neighbor if we were in class for 10 seconds and just get an idea. Okay? But maybe you tell me some ideas. Does anybody have an idea of what we can do in order to find b? And my hint to you is that this table is for the same linear equation. All these values are part of the same exact line. Okay? So I think that question was a little too broad. What we can do is we could take one of these points. I look here and I see that this is actually just the point 27. That's 27. X, Y. 2 games gives you $7. 3 games gives you $9. These are all points. Okay? These are all points. So what we're going to do is we're going to plug in 1 point, x, y, and then solve for b, because b will be the only thing left if we plug in an x and a y. I don't know. Let's see. 1 sec. No, b does not equal 7. Watch this. This is x, this is y. we're going to plug in a point. I'm going to plug in 7 because that's what the y value is for the point that I'm plugging in. Is equal to 2 times 2 because x is equal to 2. I know that's from the point. I just plugged in 2, 7. I just plugged in my point plus b. You see? You can always plug in okay, Axel, that's a good idea, but we wouldn't just need to know what game 1 is. We would need to know what game 0 before we started. That's how we'd find our initial amount. So you're right. You would subtract 2 and then subtract 2 again. Tell me if you understand what I meant. See what I mean? Okay. So look, 7 is equal to 4 plus b minus 4 minus 4. B is equal to 3. So look what I'm going to do. Put my 3 in there, and I'm done. Okay? So what did I do? What did I do? I found my slope, my m value, by finding the differences between each of our games. We know m is 2. So I went in and I used my slope-intercept form. I put 2 in for my m value, mx plus b. I didn't know my b value, so I set up my equation with my b value in it here, and I plugged in the point 2, 7. X is 2, y is 7, because that is one of my points given in the table. Given in the table. Okay, so when I plug in 2 and 7 here for x and y, 2 times 2 is 4. And then I subtract the 4 to isolate my b value, which is 3, and I put 3 right there. And that's all. So the answer is 3. Now, I'm not sure how we could get 3.5 actually. I'm not sure. Not sure. Remember what you're trying to solve for. We were looking for b value right here. Okay. This is like the level 2. There's, I think one problem like this. Okay, so you'll be able to do level 1. Then you're going to be in good shape with this. Okay. Plugging the point into the slope formula. Correct. So let's look at what we have here. Our slope-intercept form has y is equal to mx plus b. Right. Now, if I say had the point 2, 1. And I knew my slope was 3, I can find what the b value is because I have a point that is x and y, which I'm told is part of this function. If it's within the same problem, then it's always a part of the function. Okay, so this right here, I know my x, I know my y, I know my m. Look at my parts, x, y, m. What's going to be left over if I plug in all this information is my b value. So if I was plugging all this in, I'd put in 1 for y, I'd put in 3 for m, I'd put in 2 for x plus b. 1 is equal to 6 plus b, minus 6 minus 6. B is equal to negative 5. Now I could plug in the whole thing, 3x minus 5, because I just needed to find my slope. I just needed to find my b value. I found b value by being a little creative, by plugging in a point. It's a little next level. Okay, it's a little next level, but you're plugging in the point into the slope-intercept form because this is like positioning, right? This is positioning. If you want to know what my outfit looked like, you'd plug in to, your visual formula. You'd plug in, this is my shoes. Mr. C is wearing these shoes. He's wearing these pants, this shirt, right? And if you just wanted to know what belt I was wearing, you'd be able to isolate it by plugging in the things, the parts that you know, to find the part that you don't know. Okay? They'll always fit like that. It's it's spatial. It's positioning of the numbers and symbols. So you can count on that. That's why formulas are helpful. Okay? So I have to keep going. I do want to introduce exponentials. We're only doing one sample problem for that. So let me get you going on that. Take a screenshot, please. Let me open this up. I have to turn it sideways. Sorry, guys. All right, screenshot in 3, 2, Screenshot in 1. Screenshot is going away. All right, guys. Exponentials are no different. I'd like for you to try to copy this down as thoroughly / messy as you can. Okay, thoroughly / messy as you can. So it's going to be fast. You're abbreviating things. For instance, A, initial value, I probably can just write initial. I could probably just write initial. B values, you could just do ratio of change. Remember, change could be a triangle. So learn some symbols that help you write faster. And then quickly jot down this table over here. The only thing different for this, guys, is the ratio of change. That's all. Okay. The ratio of change is going to be like our difference that we found in the other table. It'll just be making a fraction. The next divided by the prior. That's it. Good. I see a lot of hard working, looking up to the screen to copy quick. Good job. Yeah, we're going to go right to the bell, guys. So let's do our best. Do our best to get this done in maybe another 30 seconds. The more you can develop your skill to abbreviate and make notes quick, the less stress you'll have in college. You want to do the notes so fast that you're done with the notes by the time they really start talking. Otherwise, you got to pay attention to two things at once. You're writing and trying to listen. Okay, so really try at West Campus to boost that skill set. Some people could take notes so fast. I had a professor at Cal. He'd write his notes. He'd write 2 lines of notes on the whiteboard with both hands at the same time. That's like 1 in a million people can do that, but you're furthest along in your version with that. Okay, there's some extraordinary people. You also need to know how to type fast. That's true. If you can get around 50 words per minute, 50 to 60, that helps. Good, really fast. Okay, let's try to get it done in the next 20 seconds. You could do it. All right, let me get this. Entertain you with some pen flipping. Oh, look at that. It's all lagging. You can't even see it. All right, exponentials. Exponentials. Remember, this is our exponential formula. This isn't new. We've seen this before. Again, it's just positioning. Look, y is equal to an initial amount, and this might be in parentheses. That's fine. Initial amount times the ratio of change. This is like our growth and rate decay. Remember the growth and rate decay? Bunnies are growing. It was 1 plus the rate or minus the rate. So with this is the ratio of change, and we're going to find that with this table method. Time is always going to be X for these guys. We don't have to do the one where I'm like, did you have it in 1 day, 2 days, 3 days? Remember how we'd find the fraction by saying that? We aren't going to do that for this. Your answer for the time is going to be X because we don't have that kind of information. Okay. Now watch. Do I know my initial amount for this problem? Tell me in the chat, what's my initial amount? Initial amount. Good. 3 goods, all good. Good. Everyone good? What's my initial amount? That was the question. Good. All right, everyone got it. My initial amount is, my initial amount is when X is 0. When X is 0, remember if this is like a graph, this is a graph. When X is 0, 5, 4, 3, 2, 1, 0, right? You're on the y-axis. That's your initial amount. That's how we've been learning it because this is time. The initial amount when X is 0 is when time is 0. Money in your pocket. Watch. Initial amount goes in this position. It goes out front. Initial amount goes out front. I'm going to put a 2. Whew. We're like halfway done. I love it. It's nice when you're halfway done. All right. Now, this ratio of change is going to be the next divided by the prior. Just like before, it was the next minus the prior. That's illegible. Sorry. Look, it's going to be 8 divided by 2. This one's going to be 32 divided by 8. This one's going to be 128 divided by 32. You see how it's the one that's next divided by the one that's behind it, because that showed you how far you went to go between those numbers, what you had to multiply by. Okay. Let's see. 8 divided by 2 is 4. 32 divided by 8 is 4. 128 divided by 32 is 4. I'm going to give you a hint. If you're doing the problem right, these are always going to be the same. If you're doing the problem right, it's always the same. Maybe make that note on the side. When you do the problem correctly, these are always going to be the same amount. Okay? So I know that I'm correct. Okay? And what we know is our b value is 4. And I know that before with linears, the b value was the y-intercept. So that might be a little confusing. But this is the traditional exponential function formula here. A times b to the x. Okay? So what do you think I'm going to put here for b? Tell me in the chat. Nice, Haley. You already had it. Yep. Cadence, gotcha. Anybody else? Good, Mia. Janice, Sophia, Haley, good job. Both Haleys.
Oh, sorry, I can't see the fractions. It's a little, yeah.
Luckily, they bought me the document cam. That's even too close. It's dang, that's too fast. Yeah, it's perfect. It's microscopic. All right, I got 1 minute. I can do it. All right, get those fractions down. We knew that we were correct. Tell me in the chat, how do we know we were correct? Tell me in the chat, remind me. How do we know we were correct? How do we know we're on the right track and we're going to get that ratio of change pretty quick? Good, Haley. Great, Abby, Rocco. Good, I have all numbers the same. They were all the same because the numbers matched. Cadence had to. They were all the same, right? Isn't it nice when it's like, you know you're on the right track when it's just like 4, 4, 4, 4, 4. Yes. So look what I'm going to put here. 4. Pin drop. Pretty straightforward, guys. I think after after seeing linear, good, Mia. Even more specific. Good job. Seeing the linear equations kind of set us up for this a little bit. You will not have the situation where you have to plug in a point for this one. You will just have to find the ratio of change. Know that is our growth factor here, our ratio of change. Initial value goes out front. Okay. Whew, that was a good one. All right, guys, give me a thumbs up, sideways down. How do you feel about this? We're feeling pretty good? What do we have? All right, I see a lot of thumbs. Good. All right, I like that thumb. Good job. All right, I'm going to go ahead and stop my recording. I'm a minute over, so I'm going to go ahead and dismiss you pretty quick here. Let's see. I'm going to stop.